Welcome to Star Chat, the podcast that explores the wonders of the universe and all its secrets. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. As we gaze up at the night sky, we're reminded of the infinite mysteries waiting to be unraveled. And today, we're going to delve into one of those enigmas, the distance to the star Deneb. Located in the constellation Cygnus, Deneb is a shining jewel that's part of the famous Summer Triangle, along with Vega and Altair. But despite its prominence, there's still much we don't know about this star, including its precise distance from us. Now, you might wonder why this matters. Well, my friends, understanding the distance to Deneb is crucial in determining its size, mass, and energy output. As we explore the history of astronomy, we find that the first star to have its distance calculated was 61 Cygni, which lies just a few degrees away from Deneb. This was back in 1838, and it marked a significant milestone in our quest to understand the universe. But despite this progress, Deneb remains an elusive target. The European Space Agency's Gaia Space Observatory, launched in 2013, has been instrumental in measuring the positions and distances of stars with unprecedented precision. However, even Gaia couldn't quite pin down Deneb's distance. The reason? Deneb is simply too bright for Gaia's sensors, which became saturated when trying to image this luminous star. Now, you might be thinking, but, Carl, what about the Cygnus Sub-7 group? Well, if Deneb is indeed part of this group, then its distance would be around 2,050 light-years. However, there's still some uncertainty about whether Deneb is actually a member of this group. As we continue to explore the universe, we're reminded that there's still so much to discover. The study of Deneb and its mysterious distance is an ongoing saga, with scientists working tirelessly to refine their measurements and uncover new clues. And that's where we'll leave it for now. The search for answers continues, and we'll be sure to follow this story as it unfolds. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue our journey through the cosmos, we find ourselves exploring the mysteries of the red planet, Mars. Today, we're going to shed some light on one of the longest-standing enigmas surrounding our celestial neighbor, the dark and light streaks that appear on the rolling hills surrounding Olympus Mons, the largest volcano in our solar system. Imagine yourself standing on the Martian surface, surrounded by an endless landscape of rust-red sand and rock. The towering figure of Olympus Mons rises before you, its peak shrouded in a thin veil of mist. As you gaze out at the hummocky deposits or aureoles that border this massive mountain, you notice something peculiar. Streaks of bright and dark colors etched into the terrain like the brushstrokes of a cosmic artist. For decades, scientists have puzzled over these enigmatic features, wondering if they might be evidence of flowing water on Mars. The possibility of liquid water, even if it's just a trickle, is a tantalizing one, as it raises hopes of finding life beyond Earth. However, new research published in Nature Communications has shed some light on this mystery, and the answer is both fascinating and unexpected. Using a machine learning algorithm to scan and catalog over 86,000 satellite images from NASA's Mars Reconnaissance Orbiter, researchers have created a map of 500,000 streaks across the Martian surface. And what they found is that these streaks are not, in fact, evidence of water flows, but rather the result of dry landslides, layers of fine dust suddenly sliding off steep terrain. The image we're featuring today, courtesy of the European Space Agency's ExoMars Trace Gas Orbiter, showcases these streaks in stunning detail. It's a testament to the power of human ingenuity and our relentless pursuit of knowledge that we can use advanced technologies like machine learning to unravel the secrets of the Martian surface. As we continue to explore the vast expanse of our solar system, we're reminded that there's still so much to discover, so much to marvel at. The search for answers is an ongoing journey, and one that inspires us to push the boundaries of human understanding. So, Let's keep looking up at the stars, and who knows what wonders we'll uncover next. Stay tuned for our final story of the day right here on Star Chat. Welcome back to Star Chat. As we continue our journey through the vast expanse of space and time, we find ourselves pondering the mysteries of our solar system's largest planet, Jupiter. Today we're going to explore a fascinating discovery that has shed new light on the gas giant's ancient past. Imagine, if you will, a Jupiter that was once as much as 2.5 times larger than it is today, with a magnetic field 50 times more powerful. This gargantuan version of our familiar Jupiter would have played a profound role in shaping the solar system as we know it. The new findings, published in the journal Nature Astronomy, are based on meticulous calculations involving some of Jupiter's smallest moons, Amalthea and Thebe. These tiny moons, orbiting at slightly tilted paths around 112,400 and 138,000 miles above Jupiter's cloud tops, hold secrets to the planet's primordial stages. By analyzing their orbital discrepancies and the conservation of angular momentum, researchers have been able to estimate Jupiter's radius and interior state about 3.8 million years after the solar system formed its first solids. As we delve into the dawn of our solar system, we find ourselves surrounded by a protoplanetary nebula, a disk of material gradually dissipating as it coalesced into the planets we've come to know. It's within this context that early Jupiter is believed to have existed in a much larger form, with a magnetic field that would have been truly awe-inspiring. The implications of this discovery extend far beyond our understanding of Jupiter itself. By focusing on directly measurable information from the planet's moons and the conservation of angular momentum, scientists have been able to bypass many of the uncertainties that often plague planetary formation models. This breakthrough not only enhances our comprehension of Jupiter, but also provides valuable insights into the evolution of other giant planets circling stars. As we reflect on these findings, we're reminded of the profound importance of understanding our cosmic history. By unraveling the mysteries of planet formation, we draw closer to grasping the fundamental question of where we come from. The journey of discovery is a long and winding one, but with each step forward, we illuminate the path to a deeper appreciation of the universe and our place within it. As we conclude today's Star Chat, remember that the universe is full of mysteries waiting to be unraveled. From the majestic gas giants to the smallest moons, every celestial body holds a secret, a piece of the grand puzzle that is our cosmos. So, let us continue to explore, to seek out new knowledge, and to marvel at the wonders that surround us. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.